it's 4 o'clock, and we will start the session with our keynote speaker. I must say I'm extremely happy to have Professor Yiannis Aloimonos, who has accepted our invitation. I have tried to invite him many times, but due to all kinds of circumstances, I didn't have the chance to listen to him recently. So we are all very happy he takes of his precious time to give a keynote speak at this conference. Let me introduce Professor Aloimonos. He is a professor of computational vision and intelligence at the Department of Computer Science at the University of Maryland in the US, and the director of the Computer Vision Laboratory at the Institute for Advanced Computing Studies. He is also affiliated with the Institute for Systems Research, the Electrical and Computer Engineering, and the Neural and Cognitive Science program. So it's pretty interdisciplinary. Professor Aloimonos was born in Sparta in Greece and studied mathematics in Athens and computer science at the University of Rochester, New York. In 1990, he received his PhD. He is interested in active perception and the modeling of vision as an active dynamic process for real-time robotic system. Recently, he has been developing active vision solutions for tiny flying agents. For the past 5 years, he has been working on bridging signals and symbols, specifically on the relationship of vision to reasoning, action, and language. So that sounds so interesting. Please, Professor Aloimonos, Yiannis, the floor is to you.
Thank you, Nadia. Thank you for your nice words. I come from the Computer Vision Lab in Maryland, which is the oldest and largest laboratory of its kind in the world. Wow. And it was established in 1965 by Professor Rosenfeld. And I'm very happy to be speaking today to this distinguished group of people in graphics. I'm also very happy to be speaking, although virtually, at the University of Geneva, because at Geneva there was Professor Piaget, whose work has been very influential on the things that I have done. So I would like to dedicate this lecture to Professor Piaget's life and works. So this action grammar that I would like to talk to you about today precedes the grammar of language, because humans, they have language for about 100,000 years, maybe 200, at most 500,000. But for the past million, 2 million, 3 million years, our ancestors, they had a pretty good civilization without language. And in my view, this cognition and civilization that they had was based on the action grammar. So working in vision, I very often come to contact with people in computer graphics. And as you know, computer vision is in some sense the inverse of computer graphics, because in computer graphics you have a model and you create an image, while in computer vision you start from images and you want to find out the models of the world. So vision is related to perception, graphics is related to imagination. The problem today that we will address is the problem of actions, okay? And the problem of the grammar of action. And the reason I would like to do that is that there exists an application of this theory to the field of graphics that is waiting to be done. So I would like to take this opportunity to introduce you to these concepts in the hope that some motivated people may pursue the application of these two graphics, and you will see soon what it is. So actions, the actions that we do, humans, or whatever entity, you may have a robot that performs actions, or an animal. They live in many spaces. So there is the visual space, which contains the representations that we use to understand some action that we see. And there is the motor space, which is basically the motor descriptions that we use in order to perform an action ourselves. And there is the natural language space, which is the word, like walk, the action. And, you know, in the field of computer vision and graphics, there exist many efforts where you try to go from one of those spaces to another. And the spaces that are interesting for the purpose of this talk is the space that goes from natural language to the motor space, that is controlling robots with natural language, or from natural language to visual space, that is natural language driven animation. So I will give you a text, and then you create a video that describes this text automatically. This is one of the goals of automatic animation, so to speak. And, you know, as Steve Jobs used to say, that in the future, the children will not be doing homework by writing, but they will be creating videos. So in order for this to happen, we have to have tools that will create that. And I think that it is essential in this enterprise to utilize the grammar of action. Okay, so what is our problem? Our problem is we're going to observe a human that performs an action. Now, to restrict it a little bit so that we can study it better, we will confine ourselves to manipulation actions. That is, things that humans do with their hands. That way we can do experiments at a restricted place. Because if we involve locomotion, humans move around, they run here and there, then it becomes a little hard. So we'll stay at a table and we'll be doing actions at that table. So we'll observe a human that performs an action, and we would like to learn a model of that action, and then perform the action with a robot. The reason that I put the robot inside is so that we remain honest, because if you have to do it with a robot, either you succeed or fail, because there are many other ways of analyzing this by working with video data sets, for example, or making predictions. So when we think about action, there are several layers at which you could investigate the problem. For example, you can ask, have I seen this before? Or something like this. And this is what people do today in Facebook and other places where they categorize, you know, this is a soccer video, or this is a hockey video, or this is a wedding video, or whatever. Another level at which you can investigate an action is you understand the action, but then can you predict what will happen next? What's the next thing that will happen? Humans and animals seem to have this capability. And then the last that only humans have is, can I answer questions about this action? Like who did what, to whom, where, and when. So you know about the grammars of language. These are rules that we have for putting together, grouping words in analyzing the syntax of a sentence. So for example, here, John hit the ball. So the ball, they merge. One is a determinant, the other is a noun. I make a noun phrase. And then with the verb, they make a verb phrase, and so on. This is called parsing. And there is a very large amount of literature on these issues regarding